Hello everyone, my name is Arnab Nigam and I am a student from grade 9 from India, and I have prepared my project for the WMI Mini Math Creative Competition on the topic P&S. P&S is a mystery topic. I'll be revealing that further in the slides. So firstly, I have a few questions about them. So can anybody tell me which insurance policy should I buy? How do I know if it will be fruitful or not? Who will win the match? Which side will the coin flip to? What number will be on the dice? Which shares should I invest in? Who will win the elections? And how will the weather be tomorrow? Does anybody have the answers to them with utmost certainty? Let's look at it. So this person here claims to know the answers. He says that there's just one thing which can help us, and that is mathematical analysis. And let me tell you, that is probability and statistics. So that is the topic for today. P and S stands for probability and statistics. Now, let us dive deeper into the concepts of probability and statistics. So first of all, what exactly do you mean by probability? So probability is concerned with the numerical description of how likely an event is to occur, or how likely is a proposition true. It's a random number between 0 and 1, where 0 indicates impossibility, that the event's never going to happen, and 1 refers to certainty, the event will always happen. The higher the probability, the more likely the event is to occur. And let me tell you that there's a common misconception that the use of probability is limited to rolling dice, tossing coins, playing cards, and such things. But let me tell you, it's much, much more than that. So what do you mean by statistics then? So statistics deals with the collection, organization, analysis, interpretation, and presentation of data. It basically deals with every aspect of data, including the planning of data collection in terms of design of surveys and experiments, recording them, further analyzing and processing them, and displaying the results or storing them. It's a very crucial process behind how we make discoveries in science and make decisions based on the data available to us and make predictions. So how are these two fields connected? How is statistics related to probability? Let me tell you, probability and statistics are related areas of mathematics which concern themselves with analyzing the relative frequency of events and probability. Probability deals with predicting the likelihood of future events, the events which are going to come, whereas statistics involves the analysis of past events, the events which have already happened. Further moving on, where can you use probability and statistics in daily life? Are they really important? So there are innumerous uses of probability and statistics in our daily lives. I have listed some of them here, which include weather forecasting, predicting diseases, medical studies, genetics, political campaigns, insurance, election poll, quality testing, stock market, quantum mechanics, cosmology, and some very famous ways to start games. You must know them, of course. Flipping coins, rolling dice, choosing cards from a deck, pulling candies from bags, and winning lottery among millions. Moving on, I'll be discussing how probability is used in weather forecasting. For an example, how it is used in real life. So everyone encounters probabilities in many aspects of everyday life, but still, it can be a concept which is difficult to master. It's not a single accepted way to interpret probabilities or to effectively communicate them. Examples of probability forecasts can be produced by several different methods. For example, a probability forecast of a weather event can be the forecaster's judgment of the likelihood that the event will occur. The forecaster thinks that it will be sunny tomorrow. So that's a weather forecast. That's a probability forecast rather. So probability forecast can be produced directly from statistical analysis of the output from these models. Like you analyze previous 10 days results and you predict the next day's result. Moving on, I have given a graph over here which will tell us how statistics uses graphs. As you can see in this region, I have given the production in tons of grains, and this is the number of years. There was some calamity which had struck at this point, and the production reduced to a lot less. It reduced tremendously from 500 tons to approximately 100 tons. After that, this, which you can see, is the current day. From that time till now, the graph has increased like this. So can you predict how will the graph further go on? Yes, we can extend the graph like it's like this, and we extend it ahead. And we can predict approximately, like if you consider the time, this time, at this time, the production will be approximately 250 tons of grains. That's just a probability. We can say nothing about the accuracy. It's highly probable that in this year, the production will lie about this point, very near to this point. So this is how we approximate things using probability and statistics, and of course, using graphs too. Moving on, if we see, probability is also used in medical sciences. So probability is a very recurring theme in medical practices. No doctor, literally no doctor who returns home from a busy day at the hospital is spared from the nagging feeling that some of his diagnoses may turn out to be unexpected results. He must have expected something, but it turns out to be wrong because there's a probability in everything. Encountering this unexpected is just an occupational hazard in clinical practices. Doctors, after some experience in the profession, reconcile to the fact that diagnosis and prognosis always have varying degrees of uncertainty and at best can be stated as probable in particular cases. Next, probability and hypothetical testing. After clinical tests, the doctor tries to find most probable diseases causing those symptoms. There are 5 major steps. Genesis of research hypothesis, which what doctor thinks which diseases have these symptoms and can this be the disease which the patient has. Next is statistical hypothesis. Which disease occurs very commonly in this area? Is it highly probable that this person will have that disease too? Analyzing each possible disease and minutely checking every detail, interpreting the data and calculating approximate probability of each disease, and finally reaching conclusions and informing the patient about it. Now here I have given a very interesting quote by William Osler. He says that medicine is a science of uncertainty and an art of probability. He too has used the words uncertainty and probability to define medicine. So you can see how important these terms are in the field of medicine too. There's another picture which you can see here. In biology, the probability is also used in predicting outcomes of genetic process. I'll show that in the next slide. So here is a graph which is called a Punnett square. This is a dominant gene of a disease and this is the recessive gene. Same here, this is a dominant and this is a recessive gene. The two dominants combine to give a homozygous dominant. A dominant and a recessive combine to give two heterozygous dominants, and there is one homozygous recessive. So if the doctor wants to tell if the parents have these two genotypes, then it's highly probable that the child will be among one of these two, because the probability of the child being a capital A and a small a is about 50%. We can never be sure about it. There is a probability in it. Both capital A's is a 25% probability, whereas both small a's is again a 25% probability. So among these three cases, a capital A, small a is more probable than the others. So this is how genetic counseling is done. If two people who are married and they want to plan a family, they want to plan children, they first consult a doctor and ask if there is a possibility of a disease which is there in their genes to be transmitted into their children. And on the basis of that, their genotypes are tested and the doctor advises them if they should go for the marriage or not. So I have covered many real life applications of probability and statistics in this presentation, and I hope you had enjoyed it. Thank you so much for watching this video. And once again, I would like to thank WMI for providing us children a wonderful opportunity to research on such interesting topics. Thank you so much.